So we look up an index first and say, okay, this piece of information is located on a document server over here. And the document server actually holds the web page in question, or web pages, because there could be many, right? That contain the term you're looking for, and we pull those up here, but we don't know which ones are the most relevant yet. So we have a list, but that list might not have the most important things first or last. So we go ahead and send that list out to a ranking server, and this is it seems like magic to people that sometimes we have the thing they're looking for at the top, but it's actually not magic at all. It's just sound engineering. We go ahead and we apply many different rules to the list that says, well, one rule might be if you have the word you're looking for in the title, it's probably something very important on that page, so that page would be more relevant. Whereas if it's in the footer, in the very end of the page, maybe it's not as important. So we take rules, 200 or so, or more of those types of rules to say, this is what's important, this is not important. We reshuffle the list around, we throw out stuff that doesn't seem too relevant, and we give you your list right back on your screen.
Okay, all that happens in about how much time?
About less than half a second.
Oh my God.
Wow.
Yeah.
That is unbelievably
That's
fast.
Faster than that. Wow, that's amazing. So we type in something, you search for basic keywords in that. That comes back to a document server, which gets ranked and back to me in about a half a second.
Yeah.
That's amazing.
Our whole goal is to get you the relevant answer to what you're looking for as fast as possible so you can get on your way.
Wow. So how are engineers involved in this process?
Well, engineers are involved in every stage of the process, from designing the hardware that it runs on to designing and architecting the system as a whole and all the moving parts. There's thousands of engineers involved in this. And as well as the ranking algorithm, which is really important. It's our page rank, which helps to determine what you're really looking for.
Okay. So the engineers that work on these large index and document servers, I mean, what are these things like? How much information are they holding?
Well, they're holding, if you think about it, we're searching the web, so we basically have to crawl with the program various websites across the internet, many as we can find, and we have to store those. And so we have these data centers that we build out servers in. And so we use cheap commodity PC hardware instead of really expensive high-end machines. And we rack those in the server racks. And we use those as storage facilities as well as processing facilities. So one of these racks could contain as much as, or even more than 100 or so terabytes of data.
So what does that mean, like in terms of an iPod?
Well, let's say you had a really big pocket. That would be 30 million songs in your pocket.
I don't have a pocket that. Are you? No.
I don't know 30 million songs.
You'd have a hard time carrying that much around now.
Yeah, no kidding. But that's the size of one of these data stacks. 30 million songs. That's amazing. That's a lot of information to serve, and it's amazing that it happens so fast. Now, you're an engineer?
I used to be an engineer. I started the engineering office here in Chicago for Google, and now I'm the engineering manager.
Wow, so you manage other engineers in this process.
I do.
Wow, that's really amazing. And like the small parts that you're talking about, I mean, why didn't you use just big, large servers?
Well, our founders actually are incredibly economical when it comes down to it. And no matter how big of a server you get, it's going to fail at some point, or one part of it will fail. And so there's different ways of going on, but if you're going to scale what we call horizontally, you can do that by buying many, many cheap servers and then writing software that accounts for failability.
Oh, very cool. So one thing I've learned is that engineers are problem solvers. What problem did this solve?
Well, at the most basic level, it's you as a user wanting some piece of information, right? Whatever it may be. I mean, back in the early days of the web, it was just text on the website. Now it's videos and music and all kinds of different information that's out there, books and libraries, all kinds of different what we call media, and we want to make sure that you get the result that you're looking for. So all of this infrastructure is very complicated, but in the end, you're looking for that 1 or 2 or 3 ideal results right there that you were looking for.
I gotta say, I use this all the time.
So basically, you guys are working to make my job a lot more easy when I'm searching for things on the internet.
Exactly.
Wow. Well, thanks, guys.
Sure.
Another thing that I'm interested in is, it may sound funny, but storing energy used from like a treadmill workout. Do you guys know anything about that, or where I might be able to find information on that?
Let's take a look and see. We get a lot of searches for alternative energy, and one of the things that comes up is IIT.
Cool.
Let's take a look. If we search for alternative energy at IIT, and go ahead and click the I'm feeling lucky button. And there you go.
So what do they do?
Well, I'm not entirely sure, but they built the Formula One, and it's also a hybrid.
Seriously?
Yeah.
Can we check that out?
Yeah, I think we should.
Nice.
Wow, Brian, thanks a lot. Thanks very much.
Thanks for coming by, Mike.
Yeah, enjoy.
Thank you.
All right.
Thanks,
Thanks
guys.
for coming by.
Oh, it's my pleasure. So cool.
Okay, we're going to IIT.
All right.
See you guys later.
Hi, Sanj.
Hi, how's
Hi.
it going?
This is my friend Jesse.
Hi, Jesse. Nice to meet you.
And we have some questions about engineers and engineering, but can you tell us what you do?
And I do research on hybrid electric vehicles. And a cool project I've been working on is actually the Formula Hybrid project.
There's a Formula hybrid car? Oh, look at this.
This
Oh,
is a hybrid?
Yes, it is.
I can't hear a thing. Look at that. Nice turn.
It's a race car that runs on electric and on a conventional engine.
That's amazing. What do engineers do?
We predominantly solve problems,
Yeah.
but we also take that extra step to make life better for the average person.
How long have you been working on this project?
With Formula Hybrid for just over 2 years
Yeah.
since it started.
I couldn't hear you when you were coming out. That's beautiful.
Built for one of those small guys.
Oh, wow. I'm Mike.
Hey, I'm John.
This is Jesse.
How you doing, John? Good to meet you.
So tell us about the car. What are we looking at?
This is a hybrid race car. In terms of hybrids, it's a series and a parallel.
So what does that mean?
Series means that it can basically run just like an electric vehicle,
Okay.
but it has an onboard gasoline engine, which acts as a generator.
How did you guys do in 2008? This is a competition, right?
Yes, it is. It's a competition organized by Dartmouth College in New Hampshire.
Okay.
And in 2008, it was held in May. And there were like 14 schools, and we actually came in third. So we were really excited about
Third
that.
out of 14 schools.
Third out of 14 big schools.
Parallel means that it can, like most of the hybrids on the road today, it can run with using the gas engine and the electric motor, which gives it a lot of power.
Okay.
So when you pulled out, you were running strictly on electricity?
Yep,
Wow.
absolutely, just like an electric car.
I'm interested in getting and storing the energy used on a treadmill. What advice do you have for that?
That's actually pretty possible. It's doable. I guess it comes down to what a generator is. It's
Yeah.
As long as you have a moving steel rod in between a magnet, you're going to create electricity. So I guess as long as on the treadmill you have some generators on the underneath that are moving, you're going to get some electricity. And the faster you run, the more energy you're going to save.
Wow.
Yes, yeah, I think that's a great idea.
Sure.
So neither one of us are engineers. How would we get into engineering?
It's really simple, really. Engineering is you see something that you think you could make better or you could fix, and you just start thinking about how you can do it.
And that's exactly what you're doing. You're thinking you
That's
can
right.
make.
So you're an engineer already.
Yeah, you're acting just like an engineer.
And I didn't even know it.
Safety first.
You find your cup holder, your radio.
I think we're ready to go.
Okay, Jesse, you got a clean car. It's been charged up. Bring it back clean and charged. That's so cool. I'm really jealous.
He's taking extra care of the car right now.
He's being very good.
right.
You know, I love the idea of science and engineering as sport. You know,
Right.
I mean,
Yeah. It
you-
makes it all fun.
You want people to get excited about this the same way that they get excited about actual NASCAR racing or
Sure.
Formula One. Now we have our speed racers back.
That's right.
All right, how was it?
I can't believe that whole time I was driving on electricity. That's amazing. That was so awesome.
Yeah, it was. You know, that reminds me, the sun is a really good source of energy too.
Well, yeah, I know that.
Yeah, but did you know how tricky it is to actually harness and store that energy? There's a group at Northwestern University. They built a solar-powered car.
Seriously?
Yeah.
Wow, those engineers are crafty.
Yeah, they are. Do you want to go check it out?
Absolutely.
All right, let's go. Go. You guys are.
My name's Michael Awadala. And I'm James Cooper. We are here with the Northwestern University Solar Car team.
Here we go.
How tall are you?
About 5'7" in heels.
Did you say 5'7" in heels?
When the sun's rays first strike the car, they come in and hit our solar cells. You can see two right here. These are actually made from a single crystal of purified silicon. When the sunlight hits the solar cells, we actually store it in these batteries.
Ah.
Yeah, so that's 624 lithium-ion batteries. Our car has 468 of these solar cells. What you're looking at here at first looks like one big solar panel, but we actually have it divided into 3 separate solar arrays. One is this half of the front car and down to here. One's the other half, and then one's the back portion right here.
Okay.
And that has to do with how we want to manage the electricity that's coming in and send it to our batteries.